myself S. Lakshmanachari, working as Assistant Professor in Department of Cyber Security, Institute of Aeronautical Engineering, Hyderabad. In this lecture, we are going to discuss definitions and terminology on multiprocessors. So, in multiprocessor system, we have multiple processors. That means more than two processors are there. More than one or two processors are there. So, in multiprocessor system, parallel processing plays a vital role, because the parallel processing is a method to improve computer system performance by executing two or more instructions simultaneously. So, in traditional computer-based system, the instructions of the program are executed in a one by one manner, one after another. So, but in parallel processing, it is a method. It improves the computer system performance. So, it is able to improve the computer system performance by executing two or more instructions simultaneously. So by executing two or more instructions simultaneously, then we can improve the performance of a system. So the parallel processing, it refers to overlapping operations by moving data or instructions into a conceptual pipe with all stages of the pipe performing simultaneously. So pipelining processing. Pipelining processing means it refers to the overlapping of the operations. So that means so basically every instruction, it has to undergo three phases. The first one is the fetch, decode, execute. So this is a first instruction. So while the first instruction is decoding, then the second instruction will be fetched from the memory. So like this. So the second instruction is fetched from the memory, then decoded, then executed. Simultaneously, the third instruction, while the second instruction is in the decoding phase, the third instruction will be fetched from the memory. So it will be looks like that: fetch, decode, execute. That means here in the pipelining processing, the segments will be overlapped. That means it is performing concurrent operations. So that's why the computer system performance will be improved. And a parallel processing system can carry out simultaneous data processing to achieve faster execution time. And the primary purpose of the parallel processing is to enhance the computer processing capability and increase its throughput. So the primary reason for using the parallel processing is to enhance the computer processing capability, and also it will increase the throughput. So the definition of the throughput is the amount of processing that can be accomplished during a given interval of time. So that is the definition of the throughput. And here in the high performance CPUs uses a technique called pipeline. So in a traditional computer system, so the first instruction will be fetched from the memory, then decoded, then executed. Then only the second instruction will be fetched. So like this. So first instruction, it will be fetched, decoded, then executed. So then only the second instruction will be fetched from the memory. So in a traditional computer based system, so there is no overlapping of the segments. Okay, so that's why it takes more time to execute the program. But in the modern computer system, modern high performance CPUs, they are using a technique called pipelining. So pipelining is executing two or more instructions simultaneously, so that we can improve the computer system performance. Okay, so they will execute like this. So whereby these phases of instruction processing are executed in independent overlapping stages. So the first instruction is fetching, decoding, executed. While the first instruction is in the decoding phase, the second instruction is fetched from the memory, then decoded, then executed. While the second instruction is in the decode phase, the third instruction is fetched from the memory, then decoded, executed. So that means at a time, so all these three stages, so three phases are overlapped. That means they are performing concurrently. So that's why we can improve the computer system performance. So that is so just before we have seen a three-stage pipeline technique. So here it is a 5 stage of pipelining. So what are the 5 stages of the pipelining? So following are the 5 stages of the RISC pipeline. So RISC means reduced instruction set computer pipeline with their respective operations. So total we have 5 stages. So in the first stage is the instruction fetch. Instruction fetching means retrieving the instruction from the memory. Okay, so once the instruction is retrieved, then in the stage 2, decoding will be performed. Decoding means generally we will write the instructions or program using some high-level language or assembly language. So as a human, we can understand the high-level language or machine understandable. As a human, we can understand the high-level language or assembly language, but the machine cannot understand these high-level language and assembly language. So that's why these are converted into the machine understandable language. And also in the decoding phase, the CPU will interpret the operation, what type of operation it has to be performed. Then after decoding, then the instruction will be executed. So instruction executive means implementing those operations. Suppose if you have a instruction add a comma b. So here we are performing a operation called addition. That means the contents of B register, it is added with the contents of the A register. So that means in the execution phase, it performs the addition operation. It performs addition operation. Then fourth stage is the memory access. So it will access the memory in the fourth stage, and fifth stage is the write back. So these are the different 5 stages of the pipeline technique. So this is how the different segments of the instructions are overlapping. So the first instruction will be fetched from the memory, then decoded, executed, then memory accessed, then write back. Similarly, the second instruction, while the first instruction is in the decoding phase, the second instruction will be fetched from the memory, then decoded, executed, like this. So like this, all the different instructions are executed in a concurrent manner. Now coming to the Flint's classification. So according to the Michael J. Flint's, the parallel processing can be classified into 4 categories. So they are, first one is a single instruction stream, single data stream. So that can be called, in short way we can call SISD, single instruction stream and single data stream. And second one is a single instruction stream, multiple data stream, that is called SIMD. Third one is a multiple instruction stream and single data stream, that can call MISD. Fourth one is a multiple instruction stream and multiple data stream, so that is a MIMD. So what is the instruction stream? So the sequence of instructions read from memory is the instruction stream, because we will store the program in the memory. So program is nothing but a sequence of instructions. So the sequence of instructions that read from memory, because the instructions are reading from the memory. So a sequence of instructions that is nothing but instruction stream. And second one is the operations performed on the data in the processor is the data stream. So in generally we are performing certain operations like addition, subtraction, increment, decrement. So these are all, so we are performing various operations on the data in the processor is the data stream. So parallel processing may occur in the instruction stream or the data stream, or sometimes in both. And coming to the multiprocessor system. So multi-processor system means a system which contains more than one processor. That is called multi-processor system. So most computer systems are single processor systems. That is, they only have one processor. So most of the computers are single processor systems. That means the systems they have only one processor. But whereas in the multiprocessor system, the system may contain more than one processor. So that's why it is called multi-processor system. Multi means many. Many processors are there in the system. So that's why it is called multi-processor system. So by using this multiprocessor system, we can increase the performance of the system. And also the multiprocessor systems are more reliable than the single processor system. And these systems have multiple processors working in parallel that shares the common computer clock, memory, bus, peripheral devices. So already we know the multiprocessor means we have multiple processors. So these are the processor 1, CPU 1, CPU 2, CPU 3, CPU n. So that means in a multiprocessor system we have n processors. So all that n processors, they are sharing the common system resources like computer clock, memory, bus, peripheral devices, so etc. So all these resources are shared by those n processors. Okay, so here all these processors, they are using a common bus. That means it is a bus. Bus means a group of physical wires. That is nothing but bus. So all these processors, they are using a common bus. So that means suppose if the CPU 1 wants to communicate with CPU 2, so the CPU 1 will send the data to the memory. So this is a shared memory. This is called shared memory because a single memory is shared by all the n number of processors. So that's why this is called shared memory. So if the CPU 1 wants to communicate with the CPU 2, so CPU 1 will send the information to the memory. Then after some time, the CPU 2 will access the data from the CPU will access the data from the shared memory. So in this way, the one processor can communicate with the another processor. So processor means it is available in the CPU. So multiprocessor. So a multiprocessor is a single computer that has multiple processors. It is possible that the processors in the multiprocessor system can communicate and cooperate at various levels of solving a given problem. So the communications between processors takes place by sending message from one processor to the another by sharing a common memory. So just before we have seen how the one CPU is communicating with the other CPU using a common memory. And the term processor in multiprocessor can mean either central processing unit or input-output processor. So in general, multiprocessor computer system, the processor mean it could be a central processing unit CPU, or it could be a input or output processor. So CPU means that is a general purpose processor. Using that it performs various operations like arithmetic, logical and shift operations. But whereas the input or output processor, it is only takes care of the operations related to the input or output devices only. So input or output devices. So that's why it is called input or output processor. And as it is most commonly defined, multiprocessor system implies the existence of multiple CPUs. Multiprocessors are classified as multiple instruction stream and multiple data stream. So already we have seen the parallel processing operations are classified into four types mainly: single instruction stream, single data stream, single instruction stream, multiple data stream, single multiple instruction stream, single data stream, multiple instruction stream, multiple data stream. So these are the various types of the parallel processing. So these multiprocessors are classified under this MIMD system. So MIMD means multiple instruction stream and multiple data stream. And the benefit derived from the multiprocessors organization is an improved system performance. So the main advantage with the multiprocessor organization is to improve the computer system performance. So this computer performance we can improve by one of the two ways. So the first way is to multiple independent jobs can be made to operate parallelly. So that means suppose if I have a multiple independent jobs, then all those independent jobs I am running concurrently. They are operating parallelly. So that they will execute in a short span of time with more efficiency. And the second one is a single job can be partitioned into multiple parallel tasks. Suppose if I have a large task, then that I am dividing into a small independent jobs, then all that independent jobs are allocated into the multiple CPUs. So because in multiprocessor system we have multiple CPUs, so like that all the independent jobs are allocated to the multiple CPUs, so that the work can be done in a less span of time. So in this way we can, by using any one of these two ways, we can improve the performance of a multiprocessor system. And coming to the comparison between the tightly coupled multiprocessor and loosely coupled multiprocessor. So we have two types of this multiprocessors. One is a tightly coupled and the second one is a loosely coupled. So a multiprocessor system with a common shared memory is classified as a tightly coupled multiprocessor. So that means in the tightly coupled multiprocessor we have multiple CPUs, but we have only one shared memory. So that shared memory is shared by all the n number of CPUs. Next, in a loosely coupled multiprocessor, each processor element in a loosely coupled system have its own private local memory along with cache memory, and the information can be shared among the CPUs by placing it in the shared memory. Suppose if the one CPU wants to communicate with the another one in tightly coupled multiprocessor, they can share through the a shared memory, and the information is transferred from one processor to another processor by using message passing system. Third one, tightly coupled multiprocessor is also known as a shared memory. The loosely coupled multiprocessor is also known as distributed memory because every processor have its own local memory. So that's why it is a distributed memory. And tightly coupled systems are physically smaller than loosely coupled system because the multiprocessor system in a tightly coupled multiprocessor system we have only a single memory. So that's why the size of the multiprocessor system is small when you compare with the loosely coupled system, and they are more expensive and they are less expensive. And example, two CPU chips on the same PCB are connected by wires etched on the board. And examples of loosely coupled multiprocessors are two computers are connected by modem over the telephone system. And advantages of the multiprocessor systems are, the first one is it is a more reliable system. They are very more reliable systems. In a multiprocessor system, even if the one processor fails, the system will not halt. So in a multiprocessor system, we have more than one processor. That means multiple processors are there. Even if one of the processor fails due to some technical problem, then the multiprocessor system will not halt. Even one processor fails, it continue to run and it continue to perform its operations with a little bit performance degradation. And for example, if there are 5 processors in a multiprocessor system and one of them fails, then the remaining 4 processors are still working. So the system only becomes slower but doesn't ground to a halt. Second one, improved system performance. So we can improve the performance of a multiprocessor system by one of the two ways. So just before we have seen, so one way is the multiple independent jobs are can be made to operate parallel, and a single job can be partitioned into multiple parallel tasks. So using any one of that, we can improve the computer system performance. And the third one is the more economic systems. So multiprocessor systems are cheaper than the single processor system in the long run because they share the data storage, peripheral devices, power supplies, etc. So in the multiprocessor system, we have multiple processors. Even one fails, it is able to run without a halt. Okay, but whereas in the single processor system, if the processor fails, then we cannot operate with that. We cannot operate with that system. So that's why they are more economical, because the multiprocessor system, they are also sharing the common resources like memory, clock. So these are all shared by the multiple processors. So that's why they are more economic systems. And coming to the interconnection structures. So in a multiprocessor system consists of set of modules like CPU, memory, IO processor, etc. that communicate with each other. So the collection of paths connecting the various modules is called interconnection structure. So in a multiprocessor system, we have several CPUs, memory, and IO processors. So in order to interconnect all those modules, we require some collection of paths that connecting the various modules is called interconnection structure. So the design of this structure will depend on the exchange that must be made between the modules. So the interconnection between the components or modules can have different physical configurations depending on the number of transfer paths that are available between the processors and memory in a shared memory system. So mainly we have several physical forms are available for establishing an interconnection network. So first one is a time shared common bus. Second one, multi-port memory. Third one, crossbar switch. Next, multi-stage switching network and hypercube system. So these are the several interconnection structures. So first one is a time shared common bus, multi-port memory, crossbar switch, multi-stage switching network, then hypercube system. And coming to the interprocessor communication and synchronization. So interprocessor communication is the communication, the process of communicating one processor with the another processor. So that is called interprocessor communication. So the various processors in a multiprocessor system must be provided with facility for communicating with each other, because they are in a multiprocessor system we have multiple processors. So one processor is communicating with the another processor. So that process is called interprocessor communication. So mainly the communication in the sense exchanging of data between the processors. So communication path can be established through the common input or output channels. So in a shared memory multiprocessor system, the most common procedure is to set aside a portion of the memory that is accessible to all processors. So this is a shared memory. So in a memory, some portion of memory we are setting aside for the exchanging of the data between several processors. So all these processors, processor 1, CPU 1, CPU 2, CPU 3, CPU n, they are accessing and they are communicating with each other using this common shared memory. So whatever the data they want to exchange or communicate, that data we are first one processor is placing the data in the memory. After some time, the another processor can read the same data from this shared memory. So in this way, one processor can communicate with the another. So the primary use of the common memory is to act as message center. So just before we have seen how the shared memory is used for the inter-process communication. So this shared memory is similar to the message center. So that message center similar to the mailbox. So where each processor can leave messages for other processor and pick up messages intended for it. So here it is a mailbox. So mailbox, and we have two processors. One is the sender processor and another one is the receiver processor. So the sender processor will send a data or information to the mailbox, and that data it is placing in the mailbox, and after some time the receiver will check for the mailbox, is there any messages for that intended receiver. If that message is for that intended receiver, then that receiver process can read the message from the mailbox. Okay. So the receiving processor can check the mailbox periodically to determine there are a valid messages for it. The response time of this procedure can be time consuming, since a processor will recognize the request only when polling messages. Next, interprocessor communication. So interprocessor communication is used for interchanging useful information among various regions in one or more processes. So the interprocessor communication definition is a process of interchanging useful information among various regions in one or more process. So this communication could be involve letting another processor know that some event has occurred, or the transferring of data from one process to the another process. And approaches of the interprocess communication. So we have several approaches in order to implement the interprocess communication, that are pipes, shared memory, message queue, direct communication, indirect communication, message passing, first in, first out. So these are all the various approaches for implementing the inter-process communication. So first one is the pipes, shared memory, message queue, direct memory, indirect memory, and message passing, and first in, first out. So in this lecture we have discussed various definitions and terminology related to the multiprocessors. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.